Now, in the earlier video we have learned how do we find the equation of a line which is parallel to x-axis or parallel to y-axis. Now continuing further, now we'll talk of general methods of finding the equation of straight line. Now there are different methods of finding the equation of straight line depending upon the information that is given in our question. What we have done is we have derived a few set of formulas to find the equation of straight line depending on what the question has told us. There are 5 or 6 methods or 5 or 6 different situations under which we can find the equation of a straight line. All of the straight lines, all those equations are linear equations in 2 variables. Every equation that we will study will be a linear equation in 2 variables. The only difference is we have made our task a little easier by forming equations or deriving equations for certain situations. Now the first situation is, or the first form of finding the equation of straight line is the slope-intercept form. Slope-intercept form. Now what do we mean by this? It means that in the question what would be given to us? Given would be the slope of the line and the y-intercept of the line. And the y-intercept of the line. We have already discussed what the intercepts are, the x-intercept and the y-intercept. The point where the line cuts the y-axis determines the y-intercept, and these two things would be known to us in the question. If we know these two things, we can find the equation of the straight line. Now how do we find this? Let's say we have this is our coordinate axis and this is our line. Let's say this is our line. This is y-axis, this is x-axis. Now let's say we know the slope of our line. Now if we know the slope of our line, either we will know m would be given to us, or we would know theta, because if we know theta we can get m by using tan theta. So let's say we know theta. And what is theta? Theta is the angle of inclination. And what is inclination? It is the angle made by the line with the positive direction of x-axis and taken anti-clockwise. Now, suppose this line cuts the y-axis at this point, and let's say this point is Q. Obviously, since y-intercept is known to us, y-intercept is what? The point where it cuts the y-axis. Let the coordinate of this point be 0, C. If you remember, the y-intercept was represented by what? Y-intercept was represented by C. Therefore, we are using 0, C. This point is C. Now, we have taken an arbitrary point on our line. The line will consist of infinitely many points. One such point is, let's say, x, y. Now, what we do is, we draw perpendiculars from this point P on the x-axis and from this point Q on this line. That is, we have drawn a perpendicular this and we have drawn a perpendicular this. Now, if you look closely, what is this length? This length would be C, the y-coordinate of this point. Let this angle be theta, angle of inclination. Now, since x-axis and this line, let's say R, let's say this is M. QR is parallel to the x-axis. Therefore, this angle will be theta. Moreover, since this is C, this length will also be C. And since the total length, this length is what? Y. That is the y coordinate. This length is what? The y coordinate. What is this length now? This length would be y minus C. And what would be this length? This would be the x. Length x, the x coordinate of the point P. Therefore, if we write tan theta now, tan theta in triangle PQR, tan theta is what? Perpendicular upon base, that is PR upon QR. What is PR? Y minus C. And what is QR? X. And what is tan theta? Tan theta is m, the slope. Therefore, y minus C is equal to m into x, cross multiplying it. What do we get? Y is equal to mx plus C. We have taken C to the right side. This is your equation of the line whose slope and y-intercept is given. This is your first form. If you know the slope of the line and you know the y-intercept of the line, you can find the equation of the line using this formula. You just have to put the value of m and c. Now if this line passes through origin, suppose our line passes through origin. Now as we had already discussed, if the line passes through origin, its y-intercept would be 0. It is not cutting the y-axis at a certain distance from the origin. Therefore, now our equation will become, now c is 0, therefore the equation of the line would become y is equal to mx. And you should always remember that any line passing through origin will be of the above form. That is, any line which will pass through origin will be a linear equation in two variables, but it will not have the constant part. That is, constant part would be 0. I hope you have understood the proof of this.